Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 10 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee. Pour it over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to write analog values using the Arduino Uno R4. Now, what do I mean by analog values? So far, with our LED, we have either turned it on with the digital write high or turned it off with the digital write low. No in between. You're either off or you're on. But sometimes we might like those in-between values. Maybe I don't feel like a full, bright LED in my face. Maybe I would want a softer, lower intensity brightness. How would you do that? You need to do an analog write. Now, next week, I'm going to show you exactly how the analog write works. But today, I'm just going to show you how to use it. And then next week's lesson, I'll explain it to you in a little bit more detail, if that makes sense. Okay, enough of this jawboning with you guys. Let's jump in and let's start building a circuit. Let's start doing some coding. So I will come over here and we will look at our Arduino. I will get out of your way. And what you're going to need is you're going to need your red LED. Remember, don't use the blue LED. That is only for special occasions. And you're going to need your 1000 ohm resistor. Remember, I use those little pliers, those little clippers to clip my legs off here so I can get a little bit more, get a little bit neater builds. And then you're going to have a red wire and a black wire. Now, does the wire color matter? No, it really doesn't. Any wire color will work. But I like to kind of help me as my circuits get more complicated, kind of help me in troubleshooting and seeing what's going on. For my power, I like to use a red wire, and for my ground, I like to use a black wire. And then, like if I have a control signal or something like that, maybe I'll use a white wire. But just develop some conventions so that you're always doing it the same, and it makes it a little easier to troubleshoot your circuits later on. Okay, so what are we going to do? We are going to come back over here and build this circuit that we have been working with, right? In the past, we've been using pin 13 as our voltage pin 13, to provide the voltage. Then we come to the long leg of the LED, then the short leg of the LED to one leg of the 1000 ohm resistor. Then we bring it on home with the other leg of that resistor coming back to GND ground on the Arduino. Now, the first thing that I have to tell you is if we are going to do analog writes, you can't just use any of those input-output pins. You see that we have the input-output pins between pin 1 and pin 13. So you see that we've got between 0 and pin 13. And for the digital writes, we could use any of them we wanted. Really, it's better not to use 1 and 0, but we could use 2 through 13. Okay, to do the digital write. But if we want to do an analog write, we can only use a pin that is designated for analog writes, and those are the ones with the little squiggly, by them. And you can see it's pin 11, 10, 9, 6, 5, and 3 have the squiggle, and it's probably shows here as well. Yeah, you can see clearly here 11, 10, 9, 6, 5, and 3 can all be used for analog writes. Now you guys forget that in my earlier Arduino lessons, one of the most common comments I have is, it only turns on and off, it's not doing the in-betweens. Well, that's because you didn't use your friend. Who's your friend? The little Mr. Squiggly there by the pin number. And so what we are going to do today is we're going to go ahead and build this circuit, but we're going to use pin 11. Why? Because pin 11 has a squiggly. So I'm going to go ahead and I'm going to put this in pin 11. And since I think I might have missed it by one, yeah. You see, I would really like to put my head over that thing, but I have to sort of stay up here where I am. So yeah, you see that's in pin 11. And then I think I'll go ahead and hook up my ground wire as well to G and D. Okay. And then let's check that. Yep, you can see that we've got ground in pin 11. Now what do we need to do? We need to put the LED in. And what I'm going to do this time, I'm going to kind of build it across this way. So my LED, the long leg is facing down, right? The long leg is facing down. Now the long leg of the LED needs to go to what? It needs to go to the voltage. So in that same column, I'm going to put my pin 11. Now on the short leg of the LED, over here, I'm going to put one leg of the resistor. Okay, one leg of the resistor will go in the same column. One leg of the resistor will go in the same column as the short leg of the LED. Okay, and it's kind of hard for me to do this from way over here, but I think I have one in. Okay, there. That was kind of painful. Probably it was more painful for you than it was for me watching me try to get it there. Okay, so now what do we have? We have one leg of the resistor in the same column, and darn it, I missed it. Let's try that again. I think what I need to do is straighten these legs up a little bit. Okay. So one leg of the resistor goes in the same column as the short leg of the LED. And boom, I got it that time. Okay, you see one leg of the resistor in the same column as the short leg of the LED. And if I said it wrong in there once or twice, I'm sorry. Now, the ground pin needs to come to that same column as the other leg of that resistor. So we should be hooked up now. Now, if you ever hook something up and it starts blinking, it's probably because you're still running the last program that you put in the Arduino, right? We left some program in the Arduino, and when you power the Arduino up, the Arduino starts running the last program that you put in it. But okay, we are set up there. I'm just going to glance at it, make sure it looks good. Yep, it looks good. And so now what I am going to need to do is I am going to need to call up my Arduino. I'm going to need to call up my Arduino IDE, and you know how to do that, right? You know how to do that. And then what I'm going to need to do is I'm going to open up bare minimum. And I know you don't see what I'm doing, but I'll switch over where you can see in just a minute. Okay, so you called up your Arduino IDE. And I think this is the view that you want. And let me just adjust that window a little bit so I make sure that you can see what I'm seeing. That looks good. Okay, now what are we going to do? We're going to come in and we're going to try to set the brightness of the LED. So what I'm going to do is I'm going to come down here in the void setup, and I need to still do a what? Anytime I'm going to work with one of those pins, I need to do a pin mode. So I'm going to do pin mode. And then which pin am I working with? I am working with, what did we say that was? I am working with pin 11, right? No, never use constants in your program. What should I use? I should use a variable. So I'm going to call that red pin. Okay, you could call it red LED, you could call it LED pin, you could call it anything, but it needs to kind of describe what you're doing. And what is that going to be? It's going to be an output. Now, if I'm going to use this variable red pin, I have to what? I have to declare it up here. So I'm going to come up here and I'm going to call it, is it going to be an integer or a float? Well, would I have pin 12.5? No, I would have pin 11, 12, 13. So it needs to be what kind of variable? An int, which are our counting numbers. What is the variable name? We said it was red pin. Okay, red pin. And we're going to set that equal to 12, like that. Okay, now we're going to come and we've got our pin mode done. Who is our friend? Our friend is Mr. Semicolon. Don't forget that. And now what are we going to do? We are going to do a digital write? No. We're going to do a what? Analog write. Okay. What are we going to write to? We're going to write to pin 12, right? No. We're going to write to pin what? Red pin. You set the variable up. Don't be afraid to use it. Now, we've got to give it a value. And what you have to understand is the range that you can go to is 0 to 5 volts. That is the output of that pin 12 on the Arduino. It can go from 0 volts to 5 volts. But here is the issue. You see, Arduino doesn't think in terms of 0 to 5. It thinks in terms of what kind of numbers? Binary numbers, okay? And so it wants a number between 0 and 255. Okay, it wants a number between 0 and 255 because that's an even multiple of like 2. Let's see, what is that? Let me see. I've got 1, 2, 4, 8, 16, 32, 64, 128, and 256. So that looks like 1, 2, 3, 4, 5, 6, 7, 8. It looks like about an 8-bit number. Let's try that. Let me try that real quick. 2 raised to the 8. Yeah, 2 raised to the 8 is 256. Okay, so you see this is an 8-bit binary number presented to us in decimal. But then you're going to ask, why are you saying 255 if it's an 8-bit number? Why don't you go to 256? Because we started with 0. And since we started with 0 and we've got 256 numbers, we can go from 0 to 255, if that makes sense. So anyway, here, if I wanted it full brightness, then I would come in, and to get 5 volts, I don't put in 5. I need to put in what? The biggest number, which is 255, like that. No, I don't put constants down here. What should I call this? I should call this brightness, like that. There's your semicolon. If I'm going to use it down here, I need to set it up here. So I'm going to call it an integer, and I'm going to call it bright, and I'm going to set that equal to 255, like that. And now if I want to change the brightness, I just come up here, because maybe I would have lots of different things that I'm doing in there. And here I can just edit the program by changing my constants up at the top. And that is a good programming habit. Okay, so now if we run this, and if we did this right, what should we expect? We should expect this LED to come on full brightness. So what we're going to do is we are going to run this, and now all eyes on the LED. It looks like it's running well, and it is now uploading and denied. So why did that not work? Okay, why did that not work? Why did that not work? Yeah, look at that. We're not on pin 12, we're on pin what? Pin 11. Now, do I have to go searching through my code to see everywhere I use that? No, I just got to what? I just got to change that to 11. Now we'll run it again. And 12 wouldn't have worked either, even if I'd been plugged into 12. Why? Because there's no squiggly there. So all eyes on the LED, boom, full brightness. And man, that is so bright, you guys can probably hardly see it. It is very bright. Let's see if I put that diffuser over it. You can kind of see it a little better, okay? But it's kind of hard to see. It's so bright, it just washes out. Now, what I want to show you is if you go from 255 to 254 and run it again, this thing is so bright, your eye is not going to perceive the difference between 255 and 254. And so when this thing comes, you see it comes back looking just like 255. 254 looks just like 255 because when something's bright, your eye saturates and it can't perceive small changes in very bright numbers. So this is kind of how you want to do it. I like to go by factors of 2. So I will go from 255, not to 254, but I would like to go to, let's say, 124, something like that. About 125, 127 would be about half. So let's say I go to 120, let's go to 126 so we keep things as even numbers. And now I want you to watch this. And this time we should see it perceivably dimmer. Okay, so it's downloading. Okay, it is compiling and it is boom. Okay, now hopefully you can see that that is perceivably dimmer than it was before. Now you guys, you'll do it at home and it'll be really, really clear to you. It's just kind of hard for me to show you here. The camera doesn't pick this up well. Now if I want to try another one, I think I would go to, let's just say 64, like that, another half. Okay, I go to 64 and I download. And it is compiling, it is downloading, and boom. Okay, you see, you can clearly see that that's dimmer. We can go to 32, download that. Yeah, and you can see that it's on, but it's noticeably dim. What if we go all the way down? I don't want to bore you guys, but you can do it on your own. Okay, I go all the way down to 1. All right, and when I go to 1, it's done now. It's so dim, you really can't see it. You can't see it on the camera, but I can perceive it just barely showing there at a 1, but it doesn't show up very much on the camera. Let's see if you can see a 4. So 1 double would be 2, 2 double would be 4. Let's see if you can see 4. Okay, so this is 4, and yeah, I can see it. I think you can see it a little bit there on the camera if I hold it up like this and you're looking down on it, you can sort of see it. But again, it's quite dramatic when you are doing it in person. Okay, so what have we learned so far in these lessons? Number 1, we have learned how to do digital writes. Number 2, we've learned how to use variables and declare variables. Number 3, we've learned to print things to the serial monitor. And then number 4, today we learned how to do analog writes. And so next week, what I'm going to show you is I'm going to show you how this analog write really works. Because if you remember, computers only know what? Zeros and ones. For the Arduino, a 0 would be 0 volts and a 1 would be 5 volts. And so if the Arduino only knows zeros and ones, or offs and ons, or 0 volts and 5 volts, how are we getting this apparent analog out with all of those in between values using a board that knows nothing but 0 to 5, or on and off, or a binary 0 or binary 1. How is that done? I will show you that next week. But I do need to give you a homework assignment. And what your homework assignment is for next week is to write a program that will start with the Arduino at its lowest setting, like the dimmest possible, a 1, and then ramp up to full brightness 256, and then ramp back down to a 1. And so the LED is going to start out just barely perceptible. It's going to bloom to full value, and then it's going to dim out back to barely perceptible. And then you'll go through the loop again, and so the LED will be going like this. Now, a couple of things you have to think about. You've got to think about how much you want to increment each step of brightness. You want to think about how you want to increment it. Do you want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 256, or would there be a better way to do it? You're also going to have to think about timing, because if you're going up and down too fast, you're not going to see it. Okay, so you got to think about those things. So you write a program that will very beautifully let that LED brightness bloom and then fade, and then bloom, and then fade. Then you need to make a short video. These videos can be 30 seconds, 1 minute, something like that. Show me your code, okay, and then show me your LED working. Post it to YouTube. In your video, leave a link back to this video, and in this video down in the comments, post a link over to your homework assignment so I can go over and take a look at it and comment, because I like to look at your homework. I like to know if you guys are picking up what I'm throwing down, you know, or if it's just going right over your head. So post that homework and I'll take a look at it. Guys, I hope you're having as much fun taking this lesson as I am making it. Want to give a thank you, a great big thank you to you guys that are helping me out over at Patreon. There's a link down in the description. If you want to help me out in that way, you can go over to Patreon and hook a brother up, okay? Or it helps me also if you give me a thumbs up, helps if you leave a comment down below. You can always subscribe to the channel. When you do, ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.